All right, so a little extra help here with polynomials 2, which is the first one that I believe you sent me. This is question number 5. This should also help you with question number 6. And also I believe there's a question on polynomials 1 that is very similar. So this question says, you drink a beverage with 120 milligrams of coffee. Each hour, the caffeine in your system decreases by about 12%. Estimate the amount of coffee in your system after 7 hours. Anytime you're increasing or decreasing by a percentage, meaning you're not going up by a constant amount, you're not going up by 5 milligrams each time or down by 10 milligrams. Anytime it's a percent, you're doing an exponential function. And our equation for exponential functions looks like this. Y equals A times 1 plus R to the t. This is something you're going to have to memorize. The A stands for your initial amount. The R stands for our rate. And that's usually going to be your percentage, and you want that to be written as a decimal. So we're going to just put decimal in parentheses here. And T right up here is going to be our time. So I'm going to kind of go through this example and see what pieces we can fill into this equation. You drink a beverage with 120 milligrams of coffee. That's what you started with. That was your initial amount. So we're going to put a 120 in here for A. Keep that 1, that's always going to be there. The caffeine in your system decreases by about 12%. The decreasing by 12%, that's our rate. Now, since I'm decreasing, I'm going to subtract it. If I was increasing, I'd be adding. And 12% as a decimal is 0.12. And the time, this tells me how long it's been. This is 7 hours. So I want to know after 7 hours what it's going to be. Now, luckily, you don't have to do that math in your head. You take your calculator, which I have right here, and we're just going to type in 120 times 1 minus 0.12 to the 7th power. And that's going to give me my answer. In this case, we're getting about 49 milligrams that's going to be left. This is going to be the same process for each exponential equation that we do. So what we did here will also work for question number 6, like I said, and I believe there's another one on polynomials 1. All right, hopefully that helped.